the ideal gas equation is often a fan favorite amongst the A-level chemists. It is like an amalgamation of various gas laws that we actually don't need to worry about too much, and allows us to approximate the behavior of gases if we're given some other kind of values, right? So you do need to know the ideal gas equation. You are not going to be given this, so you need to know that it is PV equals nRT. Let's make sure that we know, number one, what these letters stand for, but most importantly, and what the focus of this video really is going to be on, the units, right? Because the ideal gas equation lives and dies on its units. So let's start with what these mean, okay? P, of course, is for pressure. V for volume. N for our favorite, moles or number of moles. R is our gas constant. And then T, of course, is our, do you know what? I was just trying to decide whether to do a capital letter or a lowercase letter. Temperature. I didn't forget what it stood for. I promise. I promise. Okay. Now, as I mentioned before, the units are key because most students, remember this fine, can rearrange this fine, but then don't rush. Don't rush. Make sure that everything is in the correct units before you go any further. So, sorry, I just want the right pen. When it comes to pressure, pressure needs to be in pascals, okay? Often in questions, they'll give the pressure to you in kilopascals. So then you need to make sure that you multiply by 1,000 to get to the actual units that are going to go in there. Volume, oh, this is where things get a little bit tricky. Volume, it must be rather in meters cubed. And it is really the only place in your chemistry A level that you're going to see these units, right? We're so used to seeing centimeters cubed, decimeters cubed, but in the ideal gas equation, meters cubed are the standard units. Now, if we are given centimeters cubed, then we're going to multiply by 10 to the minus 6. Or if we're given decimeters cubed to get up to meters cubed, we're going to multiply by 10 to the minus 3. Okay, those are the unit conversions. Again, make sure that you've got those locked in because that's where mistakes are often made and you don't want that to be you. Okay, now going over to moles, easy. Moles are measured in moles, mole, right? No conversions there. The gas constant will be given to you within the question itself. That has got a value of 8.31 with the units joules per Kelvin per mole. Again, you do not need to remember that. You will be given that value, okay, if you need to use it. And then finally, the temperature, of course, must be in Kelvin. So if you are given the units in degrees C, you need to make sure that you then add 273 so that you get the temperature in, you get the temperature exactly as you want it. So this is your summary. Again, when it comes to putting this into practice, it really just is a case of write the ideal gas equation, rearrange it to make whatever you're trying to find the subject, make sure that all of your units are in the right units, and then plug the numbers in. Okay, so let's put this into practice. We are given the key information that we need, and we're asked to calculate the number of moles. Again, within a question, if you see they've given you pressure and temperature and volume, you know they're going to use the ideal gas equation. And the very first thing that I would recommend you doing is just write down the ideal gas equation. You don't get bonus points for just rushing and plugging everything into your calculator immediately, right? So literally, as soon as you spot it's the ideal gas equation, write the ideal gas equation, PV equals nRT, then show yourself rearranging to make the subject whatever it is that you're trying to find. In this case, they want the number of moles, so we're going to rearrange this as moles are equal to PV over RT. Again, I'm still not ready to put any numbers into this expression because first, we need to go on a side quest put everything in the right units, and only when you are happy that everything is in the correct units, then you can come back and try and get your final answer. So I'm going to split the page. I'm going to go over here, make sure my P, my V, and my T are all in the correct units. So pressure, as we've already established, needs to be in pascals. We've been given the pressure in kilopascals. So that's going to be 250 times 1,000 to give us 250,000 pascals. Our volume needs to be in meters cubed. We've been given in centimeters cubed. So that's going to be 1100 times 10 to the minus 6 meters cubed. Now, even though this is not standard form, I'm actually just going to leave it like this, okay? It doesn't really serve any benefit to now just rewrite this in standard form. I'm just going to keep it like that because it's easier. Okay. For R, that's going to always be given to us in the question. I didn't give it to you in this question, but let's pretend it's there. We know what that is. And then our temperature must be in Kelvin. We're given in degrees C. So that's going to be 60 plus 273 to give us 333 Kelvin. Okay. Only now. And I know that we've taken a detour, but it's fine because you're so much more likely to actually get the answer right if you've taken these steps to set everything out. So now plugging our numbers in, we get, so 250,000 multiplied by 1100 times 10 to the minus 6. Again, I'm keeping it like that, divided by our gas constant, multiplied by our temperature. And we end up with a final answer of, here's one I prepared earlier, 0.099. Let's see, how many significant figures would be appropriate? I'm going to go with 3 significant figures. So 0.0994 moles of whatever that gas was. Now, it may be that next they want you to figure out what the mass is, or you might need to relate that to something else. But ultimately, using the ideal gas equation, I feel like I've said this so many times, just one more time, it's all about the units. For more A-level chemistry explanations and practice questions, etc., make sure that you have subscribed to this channel. Make sure that you've liked this video, and I will see you in the next one.